This is often, and I'm just here to review some problems from the summer work packet, the written packet, not the Math Excel work, that I noticed people struggled with. So I wanted to start out by looking at some problems that involved absolute value and linear equations and inequalities. So for our first problem, we have one that I noticed a lot of people got incorrect, and that was two times the quantity 3x minus 5 plus 1 is less than 11. So here's what I noticed that a lot of people did that was not quite correct. I'm just going to change my pen here. A lot of people distributed, so you don't want to do that. What you need to do right off the bat is isolate this absolute value. So I'm going to rewrite this, start by subtracting 1 on each side. That gives me 2 times the absolute value of 3x minus 5 is less than 10. Next, continuing with my pattern of isolating the absolute value, I'm going to divide both sides by 2. That's going to give me the absolute value of 3x minus 5 is less than 5. And then I can go ahead and write my two inequalities. So if the absolute value is less than 5, that means that on the number line, I'm going to be sandwiched in between -5 and +5, because any values here between -5 and +5 are going to have an absolute value that is less than +5. So I could have that 3x minus 5 is greater than -5, or I could have 3x minus 5 is less than +5. So solving this just very quickly, I would get x is greater than 0, or I would get x is less than 10/3. Graphing that, I'm going to have open circles at 0 and at 10/3, and there is my answer. So that's the first error that I noticed people to make. So my next one is going to be an absolute value graph, and that's going to be one that we need to draw the graph of. And I noticed that people were generally okay with graphing the absolute value equation, but a little bit of a challenge in graphing the absolute value inequality. So let me just add another page here, and we're going to look at graphing the absolute value equation. Y is equal to 3/4 of the absolute value of x minus 1 minus 4. And I'm going to compare that with graphing the absolute value inequality. Y is greater than -2 times the absolute value of x plus 3. So here's my first graph. I'll notice that because this has a horizontal shift and a vertical shift, my vertex is going to be at 1, -4. So I'll go ahead and I'll graph that vertex. I also see that it's opening up because that's 3/4, and this is stretched wider because that value 3/4 has its own absolute value in between 0 and 1. So here's my vertex. And from there, I'm just going to identify a couple of extra points here. There's 1, there's -1. I'm going to go over 3 and up 4. So up 1, 2, 3, 4 over 3 brings me right about here. And that key point is 4, 0. And then to go once again, sorry, I should have gone up 3 and over 4. So we'll cross that off. That is going instead to 5, -1. And then reflecting, because this is a symmetric function, going up 3 and over 4. That brings me to -3, -1 for my reflected point. So there's my graph of my absolute value function. What I'm going to graph over here is an inequality, so not a function at all. This is going to involve shading. Noting right here, this is telling me I have that dashed line. This does have a vertical shift up, so I'll shift this up. My vertex is at 0, 3. It has no horizontal shift. It does open down because I have -2, and this is a horizontally compressed function because that absolute value of -2 is greater than 1. So I'm going to go down 2 and over 1, and then down 2 and over 1 on the other side. Now remember, because this is an inequality, I'm going to graph with the dashed lines. So this is going to get shaded. Now what I can do is toss in a test point, or you can just remember some rules for shading. I always liked using a test point just because sometimes I forget those rules. So it's going to be easiest for me to check with my test point 0, 0. Now either this makes my inequality true and I shade, or it makes my inequality false and I do not shade. So if I say to myself 0 is greater than -2 times the absolute value of 0 plus 3, well, right away I can see that this is a false statement. I'm not going to shade where this 0 is, 0, 0. I'm going to shade on the other side. So there's my shading, and that's my graph. On any test or quiz, I am looking for your graph to be correct. I'm looking for that dashed line, and I'm looking for the correct shading. So those are your key important features right there.